Now in this segment we'll discuss about next classification as time invariant and variant system. Now friends, its name itself indicates it should be dependent upon time. So let us define. A system is said to be time invariant if its input and output characteristics doesn't change with respect to time. That means even if input is delayed by certain time, the same should be replicated at the output side. The systems are said to be time invariant. And if their input output characteristics are changing with respect to time, it is known to be time variant system. Now let us take this as an example. This is our system. Here I am applying certain input as x of t, and here we are expecting an output as y of t. Now if the shape of the signal is triangular, definitely at the output side it is expected that we'll get the same kind of signal as y of t. Now I am adding certain delay to the input signal. Suppose this signal is shifted towards right side by an amount of delay as t seconds. Now if this signal is delayed with t seconds, definitely the output signal that we are expecting should be delayed by the same amount of time as t. Now if it is delayed by certain amount of time, it is also delaying by certain amount of time. So such kind of systems are known to be time invariant system, and if these conditions are not satisfied, it is known to be time variant system. Now as far as time invariant systems are considered, almost all the systems that exist in the universe are known to be time invariant. For example, if you want to turn on your cell phones or smartphones even, it will take certain amount of time. Similarly, when you want to switch it off, it will take certain amount of time. So delay is involved. The delay depends upon input and it replicates at the output. So such kind of systems are known to be time invariant systems. Now let us take one example on this. Here first equation or first example is y of t is equals to sine x of t. Now if you want to check the operation, input side we will have x of t and we are taking sine. That means we are taking sine of the input signal and that will be our operation. Now in order to prove whether it is time invariant or variant, let us take the first step. I am introducing, shall I write the same as y of t is equal to transformation of x of t, which is nothing but r, this function. So I am introducing the delay. So simply we are writing, let us introduce a delay of suppose t in input signal. So if I introduce the delay in the input signal, I am getting an output as y1 of t is equal to sine of x of t minus capital T. Say this is our equation number 1. Similarly, I will come across the output side and I can write the same statement. Let us introduce a delay of t in the output signal. Now we have the output signal as y of t, which I am writing y of t is equal to again sine of x of t minus t, equation number 2. Now if you see equation 1 and 2 both are same, that means definitely the system is time invariant system. It doesn't depends upon the time period. Say this example, y of t is equals to t into x of t. Here if you write the system, input is x of t, output is y of t, and the operation is going to be, it should be multiplied with t. Now we'll write, let us this step as it is, let us introduce a delay of t in the input signal. We are introducing delay only at the input signal, so we'll get y1 of t is equals to, t is the operation, yes, we are introducing delay in the input signal, so this is x of t minus capital T. This is our equation number 1. Similarly, let us introduce, we can write, let us introduce a delay of t at output signal. Now we have output y of t as t into x of t, which is a function of time period, so we'll get output y of t as t minus capital T into x of t minus capital T, equation number 2. Now if you compare 1 with 2, they are not same. That means equation 1 is not equals to equation number 2. Therefore the system is time variant system. Even by observation we can say here it entirely depends upon time, so it is a time variant system. Here it entirely depends upon input signal, so it is time invariant system. Let us take one more example. Y of t as e raised to x of t. Now here at the input side we have x of t, the operation is taking its exponential term and we'll get the output term. So first step we can write as it is. Let us introduce a delay of t in input signal. I can write input signal. So we can get the first function as y1 of t is equals to, operation remains same, into x1 of t. So this is our equation number 1. Here we have mistaken, it should be e raised to x of t minus capital T. Similarly, if I introduce a delay of t in the output signal, we'll get output as y of t is equals to e raised to x of t minus capital T, equation number 2. Now in both the cases the equation is same, so this is going to be our invariant system. This is our invariant system. Now in this way you can check any of the system. It can be time invariant or time variant. Thank you.